Hey guys, we're going to look at a quick lesson from class. This was why move things around. This is just called transformations in math. And one of those types of transformations is translations. Thanks for watching. Don't forget to like, comment, and subscribe. Alright, hopefully you got those objectives written down. If two lines L and L prime are parallel and they are intersected by another line, how can we tell if the angle A and angle B is shown have the same degree when measured? Just take a moment, talk about this with your partner. How can you determine if angle A has the same measure as angle B? 1 minute, go. What are some ideas you guys came up with? Yeah. Alright, measuring's that's a pretty common idea with what we've seen so far in math. Alright. Get a protractor, you put it on there, you measure it, and see if the other one has the same measure. However, in this unit, we're going to look at it differently. However, there are other ways, such as, let's say that I just kind of trace this. We'll use a different color on that. Oh, that's not bad. So, I've shown angle A right here. Okay? Now, you could measure that. However, if I didn't have a protractor, which I don't right now, I'd have to figure out a different way. Alright, so another way that I could do this is I could take this angle right here, and I could turn it, and then I can see if it matches. Alright. Now, this is a type of transformation which we saw in the objectives, which we will talk about here in just a moment. But that is another way without having to measure, just to see if they are actually the same measure of angle. In math, we move lines, figures, angles, or ordered pairs around all the time. These movements are called transformations. The figure we start with is called the preimage, and the mapped, we could have put a transformed figure on this last one, is the image. So from this, just understand, this first part it says the figure we start with is the preimage. So let's say that I started with some kind of square like this. Alright. I'm going to call it square A. Well, I tried to make it a square. This would be called the preimage because that's the object or figure we started with. Now if I take this preimage and transform it, no, not Optimus Prime. Okay. Well, I could take this thing and transform it. Let's say that I transformed it like this, kind of like this. Okay. Now that it's been transformed or mapped, we would call this the image. Not only do we call it the image, but it would be the image of A. But to show that it's the image, we give it a little mark right there. That is a prime mark. So this would read that we have image A prime. Now again, even though this is a transformation, it's not Optimus Prime still. However, it did go through some kind of transformation. We got a preimage and an image. Okay. Some other terminology we'll need to be familiar with is it's called a vector. A vector is also, well, just for our purposes, we could use array. Now that's formally, I know some math people would say this is wrong. That's okay because you guys won't have to hear these words again until like 10th or 11th grade. All right. However, in this grade we are going to hear it, and so we're going to go over it. Vector or array for us is just going to be a line with direction and, I don't know, distance. That sounds good. Just so we understand the format for this, because we may see the format, a array would have something like 2 letters representing 2 points, and then there's a line above it, but it has 1 arrow. Okay. What this means is that if I had 2 points, A and B on this thing, then I could draw a line through the 2 points with an arrow. And however, the arrow on this does not necessarily indicate that it goes on forever. It's telling us to stop at the end of that arrow. Okay? So that's why this one has distance, even though the formal definition for array says this one would go on forever. But again, we're not worried about that right now. Okay? Alright, we'll see how these are used. If I look back and I took that square A, and then I would say, hey, I'm going to take that square A and move it along this vector, whatever vector it is, doesn't even matter. Then I would take A, for example, and then move it along that vector. Hold on a second. Alright, so it's like I took this A and then I slid it up along the line right there. Alright, so that new square would be A prime again. Now that's a sliding along that vector, which we will see in this lesson.
That's freaking amazing.
Alright, at this top here it says a lot of weird words like intuitively, and right now your age you don't know what that means, and that's okay. All we want you to do right now, in fact, we're just going to ignore those two figures, just focus on this figure and also the figure right here, figure 1. By the way, this is a transformation, so I'm looking at this figure here as a preimage, and I'm going to change it into this figure, which is an image after some kind of transformation. The question is now, and you're going to talk about this with your partner, is how do you take this preimage and transform it into this image? Talk about it with your partner, 1 minute. Alright, so what do you guys come up with? Yeah? Alright, so they look exactly the same, and they do look exactly the same, yeah?
It's the same, just in a different place.
Alright, it is different. It is in a different place, though, which is important to know. So, especially in this type of math class, now we're looking at these. They are the same shape, however, one is displaced. So, how would we describe the change in position?
It slides over.
Alright, in this case, some of you guys are saying I'm going to take this and slide it diagonally up here like this. However, I could also slide it up and then to the right. Alright.
That's more work.
Now, here's the thing, though, is mathematically it's very difficult to say I slid it diagonally. In fact, it's a lot, well, diagonally is a really long word. So when I describe this, I'm going to describe it as I slid it up and right. Alright, now that we have that one for that first figure, take a moment with your partner. We're looking at the same preimage on this thing. See if you can describe and write one sentence for this, how you would take this preimage and then change it to this new image right here, image 2. Alright, what do you guys got? How would you transform this preimage to get this new image? Yeah?
Move it to the right and down, then rotate it 180 degrees.
Alright, so be careful on this one because a rotation on this, let's see what that does, okay? So we got to be careful. Flipping is very different than rotating this thing. So if I were to take this up here, the question then, because we do have a couple options, am I flipping this up or down? Talk about that with your partner. Alright, what do you guys say? Up or down?
Both.
Yeah, very good. It does not matter. I'm going to flip it. I flip mine up. Alright, now if I do that, I flipped it up, and then I've got to move it right,
Flip it up.
and then down. There we go. Alright, so that was from number 2. Now let's go to number 3. Alright, so we want to take this preimage and change it into the image 3 right here. Talk with your partner how you would do that and write a sentence on how you would do it. Go. Alright, how would you guys describe it? Yes?
Move right, and then move up, and then flip it to the right, and then rotate it.
Alright. So let's look. So move it right and then up and then what?
Flip it 90 degrees to the right.
Okay.
Not flip, rotate 90 degrees.
Alright, let's see what that does. Are we rotating it left or right? I'll let you think about it. Here we go, let's see. So again, this is after moving it right and up. Then we would rotate this thing. I've moved it 90 degrees left or counterclockwise, okay?
Is it like this?
Why is it left? It's because, like, if that was a thumb, you would be going left. Right? Left. I turned it left there.
Wait, what?
It's a left thumb thing. That's how you tell if it's righty-tighty, lefty-loosey. So if that was my thumb, I would turn it right, and then it would be righty-tighty. So the question is then, could we turn it right?
Yeah.
How far?
Degree 8.
270 degrees, bam.
Wow.
And you would get the shape. Alright, so on this one, you get to decide which way you turned it and how far. In any case, now let's go ahead and write a sentence about that then. Alright, there's the sentence that I had. 3, I slid it right and up and rotated it. All right, so here are the three individual figures that we transformed the preimage into. Just so we understand this, because we're going to need to know all three of these for this whole unit. These are the three types of transformations that have taken place. Number one, this is called a translation. One thing we need to notice on this thing, it did not change the size of the shape, it just moved where it was. Also, it did not change its orientation. The second one here, number two, that is what is called a reflection. Some of you guys use the terminology mirroring or flipping. The formal name for it in this class is reflecting. Finally, the third one, that was a rotation, which most of you guys use. Some of you guys use turning or twisting. It's the same thing as a rotation. All right, looking at these two line segments. You guys think that these two line segments are the same length? Talk about that with your partner and determine how you would find out if they're the same length. All right, what do you guys think? Are these two the same length?
Yes.
Okay, how would you find out?
Use your finger.
Use your finger, yeah? You could rotate it, that's very good. So that's very good. Technology. You could rotate it. By the way, you don't need the technology for this. The technology could just be a piece of paper. You guys could trace over it on a piece of paper and then just move the paper over.
That's not.
And then, well, let's see if this, no? It's not working. It'll work, hold on.
Hey,
It's
very nice.
Yeah, it's not very nice.
supposed to turn here. Hold on, let's get it to turn. Alright, there we go, we got it. So now it's laying right on top of there, and it is the same length, so it appears that these are the same length.
So do we write?
The technology that I'm using just allows me to do this on the screen so you guys can see it, but like I said, you don't really need this technology. What I really used was a transformation. And you guys saw what I did. I had moved it to the right and then rotated it until it was laying on top of that CD stuff line segment.
You have a CD?
All right, take a moment and then answer this last question. Why do you think we need to move things around on a plane, which is just a flat surface like we see right here? All right, why do we need to move things around on the plane? As we've seen right here, because some of you guys would say just to measure it. However, it's not always required that we measure it if we can use transformations like we just did. Not only on this one, but on the previous one with the figures that we had seen. Alright, something else you guys may want to think about is these transformations, specifically the translations that we're going over. If you think about something that you may see on like an iPad, a phone, or a computer, like an icon or an app, they use this all the time on that to displace things. So like if I wanted to move this square to the right and then down, most of those computer programs are going through the algorithm, which is a translation so that it can show the change without changing the size. Alright? Now the good thing about this is that has to do with computer coding and programming, which actually you don't need a college degree to get paid a lot for in. So if you guys can learn how to do that stuff, well, you may not even need to go to college. So you should have these written down already. So let's look at the next page. So take a couple minutes with your partner and do the extra problem, or the problem set, I think it says. Yeah, problem set. Do 1 and 2. Read those 2 questions and then answer them. Alright, describe the transformation of the preimage Q to get the image Q. What would we do to get the image Q prime? We would take the preimage, yeah? Move it up, and then to the right. Very good. And then you would have Q prime now.
Wow.
Alright, so describe this transformation that's taken place. Also with your partner, determine which of these two is the image and preimage and how you know. One is the preimage. How do we know?
Because before you, because the letters are not prime.
That's correct. Since the letters are not prime, we know that the top one is the preimage. And the bottom one with the prime marks has to be the image then. Alright, once again, these movements are called translations. Did they change the size of those figures? No, they did not.
Or the length.
Or the length. So very good. It does not change the size. This is important to know about translations. Translations do not change size or length. They only change position. That's it. So now we're on that front page for you guys' notes. So we're going to use different vectors to translate these shapes. We're going to start with Q on this thing. Let's start with Q. Alright, let's look at Q. For Q, I am going to translate this. We'll translate it along this vector right here. Alright? So that means I should be able to take that shape. Alright, now I put that that vector right on that corner, which means I can just slide this right along that corner. It's just sliding right along that vector to the edge. And this new shape here would be considered Q prime. By the way, the same vector would work for all the different corners on this thing. So we're just duplicating the same vector
Now it's 3D.
in different positions, alright?
Whoa.
Now again, I didn't need all those vectors, but you could use them just to show that we're translating that, okay? So now what you need to do,
Looks like a shape.
so you guys are going to choose vectors. You don't have to use the same vectors that I did. Use a vector if you're choosing, and then see if you can translate figure S, R, U, and V. Take a moment and do that with your partner. Keep in mind, we don't really want you guys to show this in perfection. It's difficult to do that. Technology kind of makes it a little bit easier, but it doesn't have to be perfect. Let's look at this Pac-Man figure S right here. So on this one, I am going to translate this figure. We will translate it along this vector. Alright? Actually, I'm going to need more space for that. So what we'll do is I'm going to take figure S. Oh, it's not supposed to be connected. Alright, so I'm going to take that point, which is to the corner of the mouth, and I'm going to slide it along that line.
Should be a point.
Until I get to that. A point is just easier for me to identify, because you could say, well, a point on that curve and slide it as well. So I've slid that along that vector, and this would now be S prime. Alright, so I'm going to take this, and I'm going to translate it along this vector right here. By the way, it wouldn't matter where this vector is. Like, it can be farther away. Well, if I could get to do that. Line come off of the shape, and that's okay. We can do that. Alright, so let's translate it along that line. I'm just going to slide it, again, just like this is showing. That looks about right. And again, we need to label this as V prime now. Shape V prime. So we did 3 of the shapes. Hopefully you guys did the other 2. Alright, for this diagram, we have some figures that have been translated along that translated along that vector HI. So there's some missing points on this, and also some values. What you guys need to do is label the missing points and any missing values that are known. Take a moment and do that with your partner. On this one, once again, everything's been translated along this line, or this vector HI. So if I started at this point, for example, I would translate that one in the same motion as that vector, and I would end up at this point, which means that this has to be B prime. Now correspondingly, we can label the other points as A prime and C prime. Also, the angle is missing from that, and we know it's 31 degrees. Also, from the shape we saw before, since this is G prime right here, going backwards on that vector would put us at this point. So this would just be G, and this one is F. Finally, we got this point right here, which is kind of corresponding with this one. Since that's D prime here at the bottom, this one is going to be D, and then this other point down here has to be E prime then. Also, we know the length of that is 5 centimeters, because it corresponds with this 5 centimeters here. Alright, here's the objectives from this part of the lesson. If you guys still need these, take a moment to write them down and then start on the problem set for this lesson.